So here we are, same familiar page. We'll use the same attack vector we've used throughout the course so far for error-based injection. So close off the V12 and we'll put an and 1 equals and then brackets to put that entire statement we just pulled out of SSMS in. Close the bracket, double dash to comment anything that occurs after this statement and run. And here we go. webpages_membership. Now if we have a look in the URL, and of course it's all URL encoded now, so it's a little bit harder to read, but we can see that number 7 there, and we can change that to enumerate the results. So let's change it to number 6 and see what table we get. Now here's something odd. So you'll notice that now that I've made this top 6, we're still seeing webpages_membership in the exception type. Let's make it top 5 and we'll see what we get. There's the 5. It's still web pages membership. Let's try 4. I can keep going. We'll keep getting the same result. So why can't we enumerate through these records just the same way as we did back in SQL Server? This comes back to the point I keep making about really needing to understand SQL, not just as a query language, but also in terms of the way the target database engine works. Let me show you what I mean back in SSMS. Now this is the statement that we copied earlier on, the one we're having a bit of trouble with in the web app now. And I'm going to do a similar sort of thing here as to what I did in the web app, which is make an invalid cast, just by wrapping a cast around the column name. And in this case, we'll cast as int. And we run this and we get an internal exception here talking about color. Now I was selecting the top 7. Let's try, say, the top 3. We know there's only 4 tables in the database and therefore 4 in the sys.tables table. So we'll run that at 3. We're still seeing color in the exception. Run that as 2. We're still seeing color in the exception. And the problem is related to the way the SQL indexes are built, because the order bys that you see here are actually being processed after the cast because there's no index on this name column. Now that's a real internal SQL Server semantic implementation, but it's one of the things you have to be aware of when you're trying to construct queries like this. Now there is another way that we can do this, and to demonstrate that, I'm going to take a new query window, paste in what I have on my clipboard, and run this again. Now we get president. I'm going to adjust the top results here of my inner query. We'll take that down to 3 like before. Now we've got occupation. Take it down to 2. Now we've got city. And what's actually happening here is instead of trying to select the name and order by the name, we're focusing on the object ID. So it's the same sort of logic in that there is an inner statement which selects from the sys.tables system table. It orders by object ID, and then there's an outer query which also selects the object ID and then orders by descending. And then there's a query outside of that, so this is now a third query, which actually selects the name column from sys.tables where the object ID is the one returned by that query. Now, why is this so messy? Well, by selecting from the object ID and applying that enumeration where we're changing the top number of records and then going backwards and just getting the last one, we can enumerate through and get one ID without any cast exceptions. Now, when we've got that one ID, then we can do what I've got highlighted here, which is to pull the name from the column based on ID, and then we can try casting that name to something that doesn't work. So let me show you what the whole thing looks like, and we'll indent it properly. So there's the second query, and then down here is the third query. And if we nest it back the other way, this is the one on line 4 that's doing the descending ordering. Now I've still got this on my clipboard, so let me go and drop this back into the browser, and we'll see if we can make it work. So we'll jump into where I pasted that old select statement before, down to the end of the URL, paste the query in, and run it. And now we get vote. I'll jump up to the URL. I'll have to go to the end because this one's a bit bigger. and I'm going to change top 7 to top 6. Now we get make. Let's do one more time, and we'll change top 6 to top 5, and now we will get user profile. So we are actually enumerating through values. I wanted to show it to you this way to make it clear that it isn't really a clear-cut thing. You've got to have that understanding of how SQL Server does things like indexing, and then understand how these tables need to be nested so that they order by the right column to return the right piece of data, which we can then use to cause that internal exception. The other thing I really hope this demonstrates is that SQL Server can get really complex. This is really only scratching the surface, but it demonstrates that there is a depth to it that is often more than initially meets the eye. It also demonstrates how important automation can be, because as things get more complex, yet still adhere to consistent, predictable patterns, automation becomes really valuable. And again, that is something that we're going to look at later on in the course. So that is quite a bit to take on board, but it has shown that we've been able to successfully exploit an error-based SQL injection risk to discover internal schema by enumerating through system tables. So that, in conjunction with the union-based injection that we used earlier on, shows just how powerful injection can be in order to extract really sensitive information out of the database. And of course, we can use exactly the same approach that we just saw here to extract data from the application tables as well. So we just simply apply the same logic that we have here with the name column in sys.tables to the password column in the user profile table. Exactly the same logic. And that should really demonstrate just how powerful this risk can be.